Hello, everyone. Thank you for joining us today. My name is Ryan Roberts, and I'm the Senior Business Development Manager with Alexa Voice Service, working with our technology and solution providers. Today, we're going to be presenting a webinar on our AVS development kits and a new tool that we've recently introduced for helping to explore them and get recommendations. Before I introduce our speaker, I just want to take care of a couple quick housekeeping items. We are recording this webinar, and we will send you a follow-up email shortly with a link to the recording. If you have any questions while we're going along, you don't need to save them for the end. You can type them into the chat box at the bottom of the screen, and we'll be answering some of those questions during the session, and we'll also live at the end of the webinar. So without further ado, let me introduce our speaker for today. Sammy Tao is a Principal Product Manager with Alexa Voice Service and is focused on aligning device manufacturers with technologies that help them create and deliver high-quality Alexa experiences in their products. Sammy has a master's in electrical engineering from Carnegie Mellon University and a bachelor's in electrical engineering with high honors from Texas A&M University. And he's held product development, technical marketing, and product management roles at companies in the electronics, semiconductor, and software services industries. Sammy, take it away.
Okay, thank you, Ryan. So today I'll be telling you how to use development kits for Alexa Voice Service to help save time and improve the end product's customer experience. So before beginning, I'd like to see a virtual show of hands of who have actually used AVS development kits. So here in the GoToWebinar panel, there should be an icon for a hand. Can you please raise your hand, select the button, and then we'll do a quick tally right now. Okay, so while we're counting the tallies, yeah, so we see of the participants, about 15% raised their hand. So that's great because this seminar will be tailored for you. So after the seminar, you'll understand how development kits will save you time while also improving the end product customer experience. And so for those of you that haven't used kits before, this will be key to understand the reason why this is useful. And then we'll follow with the key factors for how to select a kit. And in fact, using a tool that we introduced recently, the dev kit comparison tool that makes making this selection process easier. So let's first set with an introduction on this and specifically, what are Alexa built-in devices? What is the scope of this discussion? So we're talking about development kits for Alexa built-in. These devices simply have a microphone and speaker that enable connection to the Alexa voice service, where you can ask questions and get responses and information back. And this is opposed to the other class of devices, which is Alexa, works with Alexa. Works with Alexa devices are connected via a skill, for example, using a Lambda function, where the input to Alexa comes via an Alexa built-in device. So we'll talk about Alexa built-in devices and how do you build a device with Alexa built-in. In other words, how do you add voice to the product? So we've simplified this product development process into 4 main steps. These are learn, design, build, and launch. And so briefly, these phases are learn. So that's really understanding the interaction model of how adding voice, specifically Alexa, interacts with the use cases of the final end product. It also includes learning about hardware requirements, as well as specific Alexa features. Moving on to the design phase, that's where you as a device maker start designing your product to make it voice forward, and then follow the guidelines for the user experience, as well as functionality with Alexa, which moves into the build phase. So that's actually building the product, for example, using tools that Amazon offers to ease the experience, which include software development kits, otherwise known as SDKs, and solution providers, which include, for example, system integrators, ODMs, original design manufacturers, and focus on dev kits for today's discussion. Finally, the ultimate result is to launch the product, which includes a lot of testing, which we call certification, that enables you to receive the Alexa built-in badge, as well as marketing and launching the product. So for now, let's focus on the first three steps of learn, design, and build before moving into the launch phase. Now, just to set a baseline on some of the nomenclature that we'll be using today, and just an overview of a very simplified overview of a product architecture with Alexa voice service. So there's a diagram here at the bottom of the screen. The most basic block diagram, or a diagram that you'll see of a product with voice added to it. So there's the main product, the hardware and the software that controls the product functionality and use cases. And here we've added a microphone and a speaker as the bare minimum. There could be, of course, other peripherals such as a display or a touch screen, other types of devices not shown in this picture. There's the end user, which is this person speaking a query to Alexa. And running on this hardware related to Alexa is hardware and software that performs these functions listed on the side, which are the audio front end, wake word engine, the AVS, one of the AVS SDKs, and other AVS features. And so briefly what these functions do, the audio front end takes the utterance captured by the microphone and cleans up the utterance so that it's easier for the wake word engine to determine if the wake word has been said, for example, Alexa. In which case, once the Alexa wake word is detected, then the rest of the utterance is passed through the AVS SDK software, which essentially coordinates all of the activities of the Alexa experience. For example, sending the utterance, which we call events, sent from the AVS client, the client on this device, up to the cloud, where it's processed, and then directives are sent back, which include the text-to-speech, the voice response back from Alexa, as well as any display content. And so, for example, the speaker will then speak out the text-to-speech and or display any information on the screen. So designing products can be complicated, and especially to simplify the portion of adding voice, we recommend these options to help in the process. The first one is building with SDKs. So these are the software development kits that Amazon provides to ease this experience. The second one is prototyping with development kits. And the third one is using system integrators and original design manufacturers. These are part of our whole solution providers portfolio that really save time. Now let's dive deep a little into the development kits. So what's the purpose? What's the value of development kits? So first, let's take a look at the definition. Um, the chip providers offer eval board, evaluation boards, or reference designs. But what we distinguish is a qualified development kit for AVS, for Alexa Voice Service. So that's this reference hardware and software that these third-party chip providers produce. These are, for example, digital signal processor DSP vendors, or SoC, system on chip vendors, or MCU microcontroller vendors. And we work hand in hand to make sure that their designs are qualified for Alexa Voice Service. And what does qualified mean? So in the very last phase that we'll talk about launching a product, the end product has to go through Alexa certification, AVS certification. And the key point is that to have a design qualified for AVS, they have to pass this battery of tests, which we'll talk about on the next slide, that are derived from the end product certification tests. And in some cases, the qualification tests for development kits are even tougher than the end product certification requirements. So that's to make sure that we're qualifying this hardware and software platform, and that it will translate into final end products with a high chance or high confidence of success for passing certification. So what does all this mean for you, the device makers? First and foremost, it helps with saving development time. It's not only the OEM, the end manufacturer of the product, but also ODMs, design manufacturers who do design and manufacturing, offer those services, or system integrators who make, for example, hardware modules or integrate software components, or even can make full designs. Help save development time, because ultimately all of these devices use a chip from one of these, from a provider. So it saves development time to get this qualified with Alexa upfront, and time equates into development costs and money. So another benefit, in addition to saving development time, is really enabling the device makers to focus on the customer experience. That's really key for Amazon, to make sure that the end customer experience is very robust, and we want to make sure that the customer experience and the product quality are very high bars, meet very high bars. Furthermore, it enables device makers to focus on differentiation of their products to make sure that they stand apart from a sea of other perhaps similar types of devices. And finally, because to reiterate, the qualified dev kits stand a much greater chance of going through product certification quickly, and that's what we'll talk about on the next slides. So this is the launch phase. What goes on? There's several things that go on in the launch phase. A key one is the AVS certification process. So that's really validating that the end product meets the AVS requirements. And beyond things like terms and agreements, there's a bunch of technical requirements which are spelled out here. There's this host of tests for functionality of Alexa and playing back music. Music is a key use case for these devices. The user experience, such as the graphical user interface, or LEDs or buttons. The far field experience, because having far field added to products using voice from far away really results in a magical experience. Security, very key to Alexa built-in devices, and other features too. These are add-ons such as, for example, multi-room music, or Alexa communications, which have been covered in previous webinars. And a key way to, a benefit for ODMs and system integrators, I'm sorry, a key benefit for device makers is to really leverage the AVS qualified solutions, which include ODMs, system integrators, and dev kits, because they're really building with a proven solution. Okay, so now that said, let's take a look at the factors that go into selecting a development kit. So the top categories for considering adding Alexa are listed on this page. Let's first focus on the first 4 items, and these tend to be the most commonly ones used first, and then I'll follow with a host of considerations based on acoustics and industrial design of the product. Those of you that have downloaded the dev kit comparison tool will notice that this is essentially a very condensed version of the first 4 categories in that spreadsheet or that tool. So when we go over the tool itself, you'll see the full list, especially when you download the spreadsheet. Here, these are just abbreviated versions. For example, there's these 4 metrics: target application, the activation distance, the platform architecture, and the feature support. And then on the left side of this table are what is the definition of this metric, why it matters, and then some of the selections, the options. So for the first one, the target application, this is really what the end device type is. And so you can narrow down the kits quite quickly by identifying what is the target device type that you're building for. And then it will map into show the most relevant kits for that. The Alexa activation distance is really a metric of the distance for the key use cases of the device. In other words, are you running, do you want to be able to listen for the wake word Alexa and have the utterances be close talk, near field, or far field? Close talk is roughly about up to hand's length away. It could be up to the ear, like for a headset. It could also be for some sort of push-to-talk remote or other type of device, maybe up to about a meter or a couple of feet away. Near field, which sometimes we refer to as hands-free in the past, is something that is maybe within tabletop from a couch, for example, maybe 5 feet, up to 5 feet, or 2 meters away. And then far field is from across a room. So roughly up to about 5 meters or 15 or 20-ish feet away. And again, it's no precise definition of these. We're just giving examples of distance because the distance also, the activation distance depends on the noise conditions in the room and various other factors. The platform architecture, this is how the design, the hardware and software is partitioned to implement parts of Alexa. The cases that we have categorized are whether the hardware and software has a audio front end that's the form of a DSP, a digital signal processor, that is handling the audio front end processing separately from a main host processor, which is a system on chip or a microcontroller. So the reason for selecting this option is if you have a host processor, such as a SoC, system on chip, and you don't want to change that, you want to keep that there, and then just add on a DSP to enhance the audio input for Alexa. The other 2 choices are end-to-end solutions. So these are kits that have the full functionality, includes all of the processing, including the audio front end that's performed on as a system. So for example, an SoC or an MCU. It can also include, in some cases, a combination of a DSP and an MCU, but it's an end-to-end solution, not just a isolated DSP as in the audio front end choice. For feature support, these are additional features that are offered by the kit. For example, Alexa presentation language for rich visuals, visual content, Alexa visual content, multi-room music, the Alexa mobile accessory, for example, for headsets or devices connected via Bluetooth, where the AVS client is running on an iOS or Android device and connected via Bluetooth. Display cards, so a more primitive version of Alexa visuals, and then Alexa communications. There's also a host of acoustic and industrial design considerations, which in some cases may be the first choices that you're considering for a dev kit. And so there's a list of many of these considerations listed. They're mostly self-explanatory, so I'll run through them quickly. There's the number of microphones and the shape. You'll see this shown on our dev kit portal, where there's an indicator of the number of microphones and the shape. The spacing actually refers to some microphone configurations have to be in a very regularly spaced, a regular space pattern, but some can be variable. And this may help when the spacing between microphones can be variable, and this may help in some cases with industrial design. Mic plane orientation is probably the most complex to explain out of all of these, but basically it's the direction that's perpendicular, or sometimes we say normal, to the direction the microphones are facing. And facing means where the microphone sensors are pointing. And that's best kind of shown by example here. So there's two types of kits. You see this kit has the microphones which are pointing up. And so perpendicular to that is the horizontal position. And sometimes we refer to it as tabletop mounting. But in the kit tool, you'll see that it's referred to as the horizontal orientation. In this bottom kit, you can see that there's a circuit board with these microphones. There's actually 2 or 4 microphones on this. They're pointing out to the side, kind of parallel to a desk or tabletop. And so here, perpendicular to that is vertical. We call this a vertical mounting position. Typically, these kits that have the vertical mounting orientation are good for wall surfaces, as an example. The nominal array size is the physical measurement that we list in millimeters of the microphone array. The initiation method is how Alexa is invoked, for example, by pushing a button, a push-to-talk solution, or a wake on voice, where you just have to speak the wake word Alexa. And then finally, acoustic echo cancellation. So AEC is important for the case of when music is playing, for example, out of the device, and AEC enables the music that's playing to be canceled out from the speech that also happens to be the utterance that's happening at the same time. So you're able to barge in and speak your command even when there's a loud music playback happening. And so all of these considerations that we list in the tool are based on what we qualified in the kit. The kits, for example, in the case of acoustic echo cancellation, may support greater channels than just 1 or 2 channels, such as mono or stereo. But in the tool that you'll see, we list what we qualified. So now, just quickly, the development kits. We won't go through them in detail. This is just showing some of the past and present development kit brands. More will be coming soon. You can find this on our development kit webpage, but loosely, roughly categorized, these are audio front-end only kits. We have 6 of these with different classifications of microphones, microphone configurations. There's system kits, which are based on a host microcontroller. There's one here that is based on an MCU as well as a DSP for an end-to-end system, and actually runs with free RTOS. And then we have these 2 for headsets. And then full end-to-end system kits. These all happen to use only an SoC, a single SoC to run all the algorithms, AFE, wake word, and the SDKs for different market segments and for general market segments. So let's take a look now at some case studies and some examples of selecting a kit. So if you haven't done so already, download the dev kit comparison tool at this link, and then we'll go ahead and walk through a couple of examples live with this tool. So I'm going to go through these by memory, and Ryan, please make sure that I'm covering the all the different use cases.
Well, I can help you with that too, Sammy. So, I mean, let's just take the first kind of example that we have talked about, which is let's use the tool and build a speaker. Okay.
All right. So now on the screen is I've opened the tool. Those of you familiar with Excel, you'll know it's an Excel spreadsheet where we can filter by the different parameters. The first tab that opens are the guidelines. So these are instructions. So this infographic shows basically how to use everything. I won't walk through all of this here, but just point out a couple of key links. You can actually download the latest version of the kit here. With this link, it tells you what the version is of the tool that you're using highlighted here. You can easily clear all the filter choices with this macro button here on the left. And then finally, we welcome your feedback. We want to improve this. Please provide feedback with the link in that URL. There's also a glossary that is much more detail of the slide that I showed earlier. It covers all of the criteria, the parameters, the definitions, why they're useful, and the different options. And then finally, there's the tool itself. So let's go ahead and select a target application. I'll go ahead and clear out all the different end device types and select a smart speaker. So in this case, we'll select smart speaker. That narrows down the field to probably about 20 or so kits. And in this case, let's say I want to select kits that offer me the best far field experience. So that narrows down the kits a little bit further. And then in this case, platform architecture. So what I was mentioning earlier is we have choices of really audio front end only or an end-to-end solution. So in this case, let me start out with, I want to keep my existing SoC for example, an existing speaker product without voice, and then add on an audio front end that will help add voice capabilities. In this case, it continues narrowing down the choices to make it easier for you to select. And then just jumping to the far right, here are the kits that are filtered out. Let's say to go even further, we go to the number of mics, and to reduce cost, let's only select the minimal number of mics. Let's say it's 2, 3, or 4. So again, you don't have to select these filters in any particular order. You'll note that I just selected the number of mics here, and then we've narrowed it down to a much more manageable number 1, 2, 3, 4, 5, 6 kit types. Some of these appear the same. They're from the same supplier, for example, in this case, but there's 2 different mic configurations that are listed. So for convenience, we list each of the configurations separately. Now, let's say in this case, let's go back and clear out. So we'll do all microphones. And in this case, let's say we have the flexibility to enable an end-to-end solution with Alexa. So instead of looking just for an audio front end, we will select an end-to-end SoC solution, which incorporates essentially the DSP functionality into the SoC. And in this case, we find a number of kits here. We'll go back and select, for example, 2, 3, and 4 mics. And then that narrows down the field to a number of kits that are all end-to-end SoC. So one system on chip is performing all the functionality. In addition to the main use case of the product, it performs all the functions of Alexa. Some of these kits also support multi-room music, and this kit in particular supports Alexa presentation language, multi-room music, and calling and messaging. And you can see the kits listed here on the right. So that's an example, and then you can see here for acoustic echo cancellation, many kits were qualified with, for example, 1 channel, a mono speaker. Some were qualified with 2 channels or stereo. There may be additional AEC options that are available separately, but were not qualified. And you can see the wide range of array sizes as well, and shapes. Okay, so Ryan, why don't we try another example?
Yeah, I was saying let's take a look at another kind of area that we see as a burgeoning area within Alexa devices, which let's look at a headphone or headset.
Okay, so for headphone or headset, let's take a look. In this case, it's pretty simple, just off the bat with the target application. We narrow down to the 2 kits that are available for this. And so you could stop here and look at these two options. You could also narrow further, as well. But in this case, there's 2. These are both considered system kits, both with a microcontroller. In this case, this example, there's actually a DSP with an MCU to provide this end-to-end solution. The wake word engine is actually running on the DSP, and in this case, it's an end-to-end MCU. It actually turns out that this one is a single chip MCU based solution. They both support AMA, different numbers of microphones. One is also voice initiated. The other one is push to talk. So you can just quickly see the differences between these 2. Click on the links here to go to the websites that describe these in much more detail, finding ordering information, potential cost, and other details.
Okay, well that one was a little bit easier just because of the options. What about if we wanted to build a device that had a display with it?
Okay, so let's take a look. So smart target applications. If we do, for example, just for the here, let's say it's a smart screen device, a device with a smart screen. So in this case, we narrow down to a couple of options, about 4 options here. And in this case, let's jump to this example of feature support. So for feature support, in this example, I want to support Alexa presentation language, as a key feature, and then probably also add these really highly desired Alexa features, multi-room music and communications, Alexa communications. So I'm going to go ahead and select this one. So this tells me it's a full end-to-end SoC solution, 3-mic array, with this physical form factor, stereo AEC, and it's the Amazon Alexa Smart Screen Development Kit. Alternatively, another way that I could have come across this kit, let's say I just want to, I know that I have this feature that I want supported because it's a device with a display. I know that I want to support Alexa presentation language. So in this case, I would go straight to this criteria, select APL, and then I can see that there are kits that are applicable for speakers, smart screens, set-top boxes, TVs, and soundbars. And if you look closely, the parameters are all the same. It turns out that these are all the same development kit, which is Amazon's own kit. It's named the Amazon Alexa Smart Screen Development Kit. It is our collection of best practices for implementing Alexa features, including screen-based devices. It can be used for devices with or without a screen. It includes all of the key features such as multi-room music and comms and other features. It's available to qualified device makers upon request, which you can access at this link, but it's available strictly to device makers building commercial devices. Okay, so you want to try another one?
Yeah, we'll do one last example. So as we know, one of the another big market that we see opening up is within the smart home space. And so previously a lot of those were works with Alexa devices, but now we're looking to bring Alexa built into those. So what are some kits that we have for that?
All right, so let's look at the category of smart home. And boom, we get a couple of kits here. One is an end-to-end solution based on a host microcontroller, and then end-to-end SoC. And if we look here, this is the one kit based on a microcontroller for very resource-constrained devices. And then we have this other kit, which is based on a SoC, a system on chip to provide more processing capability. So we could narrow this down further as well if we had particular array size constraints. But if you know that you want to use a microcontroller, then it's pretty easy to pick that out of this selection. Okay, so now we've gone through the examples. So in summary, today we covered how development kits help save development time, as well as improving the customer experience, as well as the quality of the end product, and enabling greater differentiation. We also talked about the key factors for selecting a kit, as well as how to use the dev kit comparison tool that was introduced. And so for next steps, please download the tool if you haven't already. Use the tool to identify the kits that are most relevant to your applications and start your design today.
All right, thanks, Sammy. I appreciate it. That was a lot of great information there. And so during the time, we've received a number of very good questions. We'll get through as many of those as we can now. For those of you who have questions that you haven't submitted yet, submit your questions and we can hopefully have some time to answer them before we're done. So, all right, let me pull up the questions here. All right. So we've walked through the tool. The Excel spreadsheet. Is there plans to make that a web-based tool, or is it something that will continue to have to be downloaded?
Yeah, so this is the very first iteration of the tool for convenience. It's currently an Excel spreadsheet. We are investigating other ways to enhance the developer experience. For example, perhaps making a web-based tool to allow greater, sorting options and selection criteria. So yeah, it's something we're considering. We'll have periodic updates of this tool based on new kits, for example, that we introduce, as well as improvements to the tool itself.
Okay, great. Thanks, Sammy. How does Amazon select which development kits plan to qualify?
Yeah, so that's a good question. So, like Amazon's philosophy, we always start with the customers and work backwards from there. We primarily look at the key use cases of customers using Alexa, and then figure out what are based on those key use cases, what hardware and software we need to enable to make that experience easier for the device makers. And so the combination of talking to customers, end customers, as well as device makers, we prioritize those hardware and software reference designs in the form of qualified dev kits based on priority. And so we prioritize those and then bring those to market. Help the chip providers bring those to market.
Okay, great. And then if I had a development kit that I wanted to qualify, who do I contact?
So there is a link on the developer site where you can submit feedback. I believe there's also a link in the tool where you can submit feedback as well with an email address, and then we'll definitely consider any requests that come in. Please send your feedback, and we'd be glad to hear either other kits that you'd like to see, as well as feedback on the tool itself.
Okay. Let's see here. We have another question. It says, is there any possibility of incorporating a camera in order to work with image recognition APIs, for example?
Yeah, so some of the kits that are mentioned that are on that have been qualified do include camera support. There's currently, so those would be third-party APIs not tied into Alexa functionality. We're investigating making camera functionality in support of Alexa available, but none of the kits support that today.
Okay, thanks, Sammy. When should I care about stereo, acoustic, echo cancellation?
So this depends on the quality of the end product. So if the end product has stereo speakers or maybe more than one speaker, then it'd be appropriate to start considering stereo echo cancellation because that algorithm in the audio front end will help subtract out that music that's being played back in stereo from any speech utterances, which will make it easier for Alexa to understand when she needs to be responding to an utterance and to send the utterance to the cloud. So that's when it's most important, when you have two or more speakers.
Okay. How can we use the tool to identify target applications that are built using microcontrollers such as a Raspberry Pi or Arduino?
So the question is, how to identify dev kits that are appropriate for building kits like Arduino or Pi, but the way I'm interpreting this is that most people are not building other dev kits or evaluation boards per se. If that's the case, then I would look at a general kit, perhaps one that supports display-based devices, and use that as a reference design to figure out how to make a Pi or Arduino enabled with Alexa voice service. The latest generation of Raspberry Pis are based on SoCs, but if you have a board that uses a microcontroller, then you could look at the MCU-based kits, for example, the one that's shown under Smart Home. But I think maybe a more general question is, if I want to design a system with a microcontroller and I'm just doing some prototyping, how do I identify the kit? I would first look under Smart Home or look under the selection criteria, for example, for end-to-end MCU, and those will have options.
Okay, let's see. Who provides the wake word engine, Amazon or the MCU or chip provider?
Yeah, so there's all of these providers can provide the wake word engine to qualified developers. Amazon can provide wake word engine, tested with many different in the locales where Alexa is supported. There's also third-party providers that offer wake word engines, either purely in software, or that perhaps come bundled with digital signal processors, for example.
Right, yeah, I can help a little bit with this. I work with our wake word engine team too. So yeah, so for those of you who are asking that, then we got quite a few questions about the wake word engine and things like that. The Amazon wake word engine is typically the preferred wake word engine, and we can provide that for developers who are looking to build devices. Synaptics has their own wake word engine, which has been qualified for far field if you're using one of their DSPs or one of their DSP or one of their development kits as well. And then there's other third-party wake word engines that are out there. So another question that we got relates to custom wake words. Are there any kits that support wake words beyond Alexa or custom wake words?
So we have not qualified any kits other than those with the Alexa wake word. So you can feel free to add on to that, but we have not qualified any to date.
Yeah, and so right now for Alexa functionality, Alexa is the only wake word that works for AVS Alexa voice service devices. So we had a couple questions also related to ordering dev kits. How can people order dev kits?
Yeah, so with the exception of the Amazon Alexa Smart Screen Development Kit, that one is available from Amazon to qualified device makers who are building commercial devices. There's a link on the website you can find through this URL and go down and navigate to the development kits page. The other kits are all available from third-party chip providers on their respective websites or pointers to their distributors.
Okay, great. Let's see. Can I use a far field kit as for near field, or is this just a profile change parameter?
Yes, you're certainly free to use. In some cases, far field for near field, it should work just fine. So yes, the answer is yes.
How many different Amazon wake words exist? Like, are there different versions for far field versus near field, et cetera?
So do you want to go ahead and address that, Ryan?
I say, yeah, I guess I can. So it's not so much there's different wake word engines. The engine is the same, but we do have different models that work. So for a near talk or close talk scenario, we have much smaller models that run that would not typically work for a far field scenario. For far field, we have additional size models depending on the resources that are available within the device itself. So we have larger models that require more memory and more MIPS, but we also have some smaller ones we consider low power models that still work for in a far field application. So typically those run around the low power ones are around 250K for those models, and for the larger models, they run about 800K. And really the primary difference is just the amount of training data in them. So accuracy is both great, both are qualified for far field. So you're not getting one that's worse than the other. So. All right, let me find, we've had a couple more come through here. Let's see. Do we have, in the tool itself, are there a list of ODMs for each of the different product types that are included in the tool, or is there somewhere else where we can find information about those ODMs?
So the answer is no. The DevKit comparison table tool focuses on development kits, and those providers. We do list ODMs on our website, which you can get to from this Get Started link and navigate into designing and building with AVS. And there's a section on solution providers and a list of some of the ODM designs. Feel free to contact your local Amazon business development representative for additional details as well.
Okay, so do these development kits all run the same software stack, such as the AVS device SDK, or are there different SDKs that they're running?
Yeah, so these kits are running, most of them are running the device SDK, sometimes known as the C++ SDK, in different forms. And then some are running other types of SDKs that are more tailored toward the product types or the end use cases.
Okay, we'll do one last question here. So with the Amazon Smart Screen development kit, you mentioned that it was only for qualified product developers. What is the definition of a qualified product developer?
Right. So those developers that are building commercial devices, we would consider qualified. And then after we receive the submission, we'll prioritize that request according to the other requests that we've received.
Okay, great. All right, I think that's a good place to wrap up the webinar. Thank you, Sammy, for the great presentation, and also a big thank you to everyone for attending today and for submitting questions. As a reminder to everyone, we will be sending out a recording to all the registrants either today or tomorrow via email. So take a look, be sure to keep your eye out looking for that email. And I just want to say thank you for everyone joining us. All right, have a great day.